Okay, so now looking at some ways of interpreting some of the things that we can get from these basic toolkit functions. Here's X, here's Y. Let's say somebody throws a ball. From this point, the path of the ball is going to be a parabola. The ideal path of the ball is a parabola. There's some air resistance. This is a very good parabola. It's extended too far that way, but still. Yeah, maybe it isn't that bad. Okay. Okay, point is, that's the ideal path of the ball. That's the ideal path of, let's say somebody's doing the shot with a 16-pound shot. The best people in the world can throw it about 70 feet. So you take a 16-pound shot and, shoulders a lot of times I can't do good imitation. Used to be fairly good at shot, actually, for a skinny guy. Okay, so that would be a good model for a shot point. Okay, it's released at a point that's above the ground because you got first. Okay, I've got an arm, and that's his legs are too long, but you get the idea. Okay, and thing goes out to here. This is just again going to have the shape of the basic toolkit function, but it's going to be distorted somewhat. The red dot's going to go here. It's got to be flipped over. It's got to be upside down. So maybe really a bad diagram. And that's, I don't know what I just did. It wasn't good. Okay. Teaching me to talk before I think. Red dot's going to go here. And we could draw a rectangle here. And using the corners of the rectangle and the dot, you get this portion of the parabola. Okay. Well, so be it. In this case, if we know X, okay, so let's say this is 48 feet. Okay, say this is 50 feet. So this is maybe 35 feet. Okay, and how high is the shot at that point? Well, say this is 5 feet, so this is maybe, let's say, it's probably at least a little higher than that. These are big guys. Okay, so let's just say that 12 feet is here. Not a very realistic model, but it's okay. Okay, so when X is 35, can you estimate how high the shot is? At 35 feet, how high is the shot? Okay, well, come up to here, over here, and there your is. If this is 12, that looks like it's about 10. Meaning if you're standing here, you're probably safe. It's probably not going to hit you, but you don't want to be standing downrange, especially somebody really strong is throwing a 16-pound shot and kill you. Okay, so stay out of range. Anyhow, that's one application. Okay, you got something in flight. Could be a baseball, could be a shot, could be a golf ball, a stone. Okay. And again, we kind of ignore air resistance when we're doing this, but there's the idea. Okay, so that's one application of your basic parabola. You'll see another one fairly short. Okay, let's take this exponential function. Now I've labeled the axes X and Y. Instead of X, I want to use T. Because we're going to interpret this as time. We have our basic shape. Something like this. So we put our red dot here, but we expand our rectangle. So I'm going to want to draw it like this. Then we're going to start here. We'll go through here about like this, and go up here. Okay. Now, what might this mean? Y could be the value of an investment. P could be time in years. If this graph has the shape of a properly constructed exponential graph, you're going to be able to predict the value of an investment at some time down the road. So let's just say that this is 40 years. Let's say that your initial investment was $5,000. Okay, so how much you're going to have after 20 years? You can predict it. How much you're going to have after 10 years? You can predict that. 30 years? You can predict that. Now there's algebra involved, and it's somewhat challenging. Depending on how good your algebra is coming into the course, you might find it more or less challenging. Some people come into this course already knowing about logarithms and stuff which you would use to solve equations here. For example, if you wanted to know when your investment reaches, let's say, $15,000, let's say that's here, you estimate your time. That's relevant to your personal finance. Most of you are going to be around for at least 40 years. You want to start taking advantage of exponential growth quickly. Now, don't take financial advice from me. I'm not a financial expert, although I know the mathematics. But get some good advice. As soon as you get some money, start doing intelligent things with it. Okay. There's just one example of why this is important. Another example, I got some tomato sauce in a jar. I throw some spices into it and want to make it into a good tasting spaghetti sauce. Okay, I put it in the microwave and it comes out of the microwave at a certain temperature. And the temperature decreases according to an exponential curve. That's like we reverse this thing. So we can also flip this thing left and right. So that's kind of a left and right flipped. And I want to know how long the thing stays at cooking temperature. So I observe temperature comes out at, a few minutes later, I observe the temperature here, cooking temperature ends right here. I can sketch a graph and make a good estimate. I know how to sketch these graphs. Turns out if you put a towel around it, a quart jar of tomato sauce, starting at 200 degrees Fahrenheit, that will stay above 160 for well over an hour. So that's enough to cook the stuff. Okay, practical. If you can visualize these kinds of curves, you can make better decisions. Okay. If you happen to be in charge of a restaurant and you're the head chef, you can gain more insight into the cooking process if you're aware of some of these things. And if you're coming up with instructions for all the cooks and a whole chain of restaurants, you'll actually want to crunch the numbers. Okay. Or you're going to get somebody to crunch the numbers. You're going to want to understand what they're doing. Okay. Now, unlikely that you're going to end up being in that position in a nationwide chain of restaurants, but maybe. But there are all kinds of examples where this kind of thinking can be beneficial to you. Okay, there are models for the reciprocal function, but I'm not going to talk about those right now. They're actually pretty simple models. Okay, these models are a little more complicated than the models you get here. And we're going to see examples of this soon enough.